Let's have a look at absolute value and its formal definition. I mean, the formal definition of absolute value might seem silly, but this is what it is. I mean, absolute value of A is A if A is greater than or equal to 0, but it's negative A if A is less than 0. What we're basically talking about is a distance. So I don't care whether it's on the negative side, I don't care if it's on the positive side, I just want to know how far away is it from 0. That's basically what absolute value is. Right? So for those physics people amongst us, it's magnitude only, direction is not considered. Right. So we'll start with a fairly basic one. Absolute value of -5. I was expecting, yes, very good. It's positive 5. Okay, absolute value of 6 minus 8 minus 2. Absolute value is like grouping symbols. You always do what's inside them first. So 6 minus 8 minus 2 is -4. We get 4. But that means when I get something like this, I do what's inside the absolute value symbols first. 6 3 is 18 minus 20 is -2. So 7 minus the absolute value of -2 would be +5. And because they are like grouping symbols, then I don't need a multiplication sign. It's just like writing 3 in front of the parentheses. So 3 times the absolute value of -6, 3 6s, 18. All right, so how do we go and solve an equation involving absolute values? Now, this is a very simple one, of course, and a lot of people will write it down and just say, oh, well, x is plus or minus 7. That's not really the way we solve it, though. We go back to the definition. And now, it might look like I've written the same thing down, but I haven't. What I've done is I've said, oh, there's 2 possibilities. There's one when x equals 7 and one equals -7. That's exactly the same thing. No, it's not. Because here, when I have 2x minus 3 equals 7, I don't write down 2x minus 3 is plus or minus 7. I write down either 2x minus 3 is 7 or the negative of 2x minus 3 is 7 because it goes back to our definition. The absolute value of A is either A or negative A. So therefore, the absolute value of 2x minus 3 is either 2x minus 3 or the negative 2x minus 3. It's not the 7 that's changing the sign. It's the absolute value that's changing the sign. Now that might seem trivial to you, and I suppose with equations it is. But when we come to inequations, it's very important. Or we're going to get the sign mucked up when we go and solve things. So x equals 5, x equals -2. There's our 2 possibilities. Still only 2 possibilities, but it's 2x plus 6 or the negative of 2x plus 6. Left-hand side comes to be x equals 7. Right-hand side, x equals -1. Here comes the big mistake. Checking. We don't do it because we're terrible at doing it. We just solve equations and think, I'm all good, here's my answers. But it doesn't work. Sub in -1, the right-hand side becomes -4. How can the absolute value of something be -4? It can't. So -1 is not a possibility. The reason why it doesn't work is because we have changed the question. In order to solve the absolute value, we said, okay, look, yeah, this is a bit hard to solve. I'm going to solve these 2 new equations. And whenever we change it, there's a chance that we will create new solutions. And in this case, we have. We've created x equals -1. It is a solution to this second equation that I rewrote. However, it's not a solution to the original question that was asked. And that's why it's important. If we have manipulated our equation in some way, just to have a quick check. So the only possibility is x equals 7. Reality with these sorts of things, it's only ever going to happen when I've got absolute value equals algebra. Because if it's a constant number, well, then you know whether it's positive or negative straight away. It's only the algebra that's causing the problem. Inequalities. This is the one I was taught in equation. Get the word right. In equation, okay, it's important to do it using the definition. Either x plus 5 is less than 2 or the negative of x plus 5 is less than 2. In this case, if you went x plus 5 is less than plus or minus 2, it's wrong. Because if you look at the negative case over here, I could turn that into -2, but if I change the sign, change the sign. And if people that do it with the right-hand side going plus or minus, they lose that and often get it wrong. So stick with the definition. Absolute value is what changes sign. X is less than -3, or X is greater than or equal to -7. So we've got to think about that solution. Is it an or is it an and? Is it possible for both to happen or not? If you're unsure, get yourself a number line. Let's see, -3, greater than 7. Oh, okay, this is an and case. We're in the middle here. So X is in between -7 and 3. Let's have a look at this one. So again, it's the absolute value that changes sign. First one, I get greater than or equal to -1/3. The other becomes less than or equal to -1. Again, is this an or? Is this an and? Let me have a look. This must be an or. Impossible for that one to be an and. So it's less than or equal to -1 or greater than or equal to -1/3. Now let's look at the graphs. What is the effect of finding the absolute value of a function? Well, it means the y values can only be positive. So in the original graph, whatever was below the x-axis is reflected above the x-axis. As opposed to y equals function absolute value x, now what we're saying is we're only going to substitute in positive numbers. So when I substitute in -2, before I substitute it in, it changes to +2, sub it in. So this time what happens is the left-hand side of the original graph just disappears because we could never sub in a negative number. But it's replaced by the reflection of the right-hand side. Right? So it's reflected in the y-axis. Now, this will not be immediately obvious, but I'll show you. Y equals the absolute value of x, a graph I hope you're all familiar with. Ta-da! Now, I could say it's y equals x, but the absolute value of it. So what was below was reflected above. Or I could have thought of it as, no, it's function absolute value x. So y equals x, left-hand side disappeared, and what was on the right was reflected across. Either way, thinking for that one. Right? Probably good to label a couple of points on there to give it some scale. Otherwise, all your drawings are V. And people go, what is it? So let's try it with this one though. Y equals the absolute value of x plus 2. So the basic graph is y equals absolute value of x. But what have I done? The 2 is grouped with the x in the absolute value. So it's a horizontal shift. We have shifted left 2 units. That's one way of thinking about it. I could have done it this way. There's the basic curve, y equals x plus 2. We're saying the absolute value of the whole function. So what is below is reflected above. That's another way I could have done it. Right? How about this one? Y equals the absolute value of x plus 2. I could say it's my basic curve, y equals the absolute value of x, but I've shifted it up 2 units. I could think of it like that. Or I could say, well, it's the basic graph, y equals x plus 2, but in this case, it's function absolute value x. It's only the x I've made absolute value. So whatever's on the left will disappear, and whatever's on the right reflects over. And we get our graph. Let's have much more fun with things like this. Don't have to be straight lines. Absolute value of x squared minus 2. Well, there's y equals x squared minus 2. So whatever is below is reflected above. We get a nice neat graph there. I want to solve. I could use a graph to solve this. I'm not saying it's the best way of doing it. But if I did, okay, there's the absolute value of x plus 5. There's y equals 2. The question is, when is the blue graph below the red graph? Between those two x values, still got to solve the equation to find out what those values are. They turn out to be -3 and -7. So, that's a graphical way of solving, but as I say, probably wouldn't be your first option, unless you happen to have already drawn the graph, I suppose. Okay, I thought I'd give you some space.